Reed. Uh, Welcome back, everybody. Today is our last official day for our program. It's been a long 3 weeks, I think, for some of us. So I'm sure some of you guys kind of glad to reach this part. For those of you, looking forward to Adventure Platoon, keep at it. Make sure you guys are, if you should be close, if not finished with your part two assessment. Um, Mainly because you still have to schedule it, right? Um, so today is Thursday, so make sure that either no later than probably like tomorrow, should you be submitting your application. Um, right? Just a quick disclaimer, right? So, although there's only 10 of you guys here in this call, right? You guys are not the only people who have been learning to code, right? There's other people who, just like Keegan, have not partaken in either guide application, or for those of you who are here as an intro to coding course, they have been going through it at their own pace and are still going through the application process, and signing up for these live technical interviews. So Guillermo is our admissions man. So he does work. I believe he works at Amazon. So when he does these interviews, it's when he has his time off. So make sure you guys do schedule that as soon as you guys can, to make sure you're on his schedule. Um, but all right. So yesterday we kind of finished off mini project two. Um, well, we didn't finish it off, right? We started it, we broke off into groups. We gave it an honest try. Some teams did a little better than others. Does anybody want to, before we get deep into our last mini project, does anybody want to show their code if they completed it? Right? Does anybody have a completed product maybe after we got off yesterday or today? You guys continue work on it? Anybody want to kind of just showcase the output, just shows how it worked?
I mean, it's not clean, but it works.
Yeah, I
Like,
mean, go ahead. Just kind of show what you're able to accomplish. Let me go ahead and stop sharing my screen.
all right. All right. So something that I struggle with is naming functions. So please bear with me because they're just not specific enough. And I just kind of slap them on there. But essentially I've imported random because that's what we're going to use to select our balls. Just to print a little welcome statement. This first function right here, select numbers, is for the player. Essentially, I've set up a variable at my Powerball as a list, and while the length of my list is less than 5, we're going to be running through this while loop. So it'll give uh, the input to select a number between 1 and 69. That'll be our variable Powerball. If the Powerball is already in my Powerball list, then we're just going to print this statement and we're going to continue on. We're going to try again. If the Powerball is not in the range that we set it to, then we're going to just skip this and try again. Um, if none of those are met, then we're just going to add it to our Powerball list till we have a full 5 numbers. After that, we're going to do a quick sort, since the Powerball is assorted by ascending numbers, apparently. And then we're going to add the actual red Powerball here at the end. I do not have any what do you call it, but measures to handle bugs with this. But while my team was working, this was good enough just to get our code up and running. This one is pretty similar, except no user input. This code looks scary, but essentially what I'm doing is I am using list comprehension. So is this right here is just a placeholder for my for loop there. So in the range of 5, for every time we go through the loop in the range of 5, we are going to add a random integer between 1 and 69. and we're going to cast it as a string. So that's going to run 5 times. We're going to sort it, and then we're going to add our Powerball using the same method, using a random integer. Our last, I believe, our second to last function is just checking if you won or not. So again, bad with names. I need to work on this. This Powerball is what would be drawn. This isn't the player's Powerball. So we would create that. We would use my Powerball selection as the argument. And this is where it gets a little bit funky. So again, bear with me. I'm using I and selecting the length of my selecting my number based on the length of my list. Since I don't want to access this last variable, I've subtracted 2 from the length to access indexed number 4. So basically, this while loop is going to run, and it's going to check back to front if there is a match between the two lists. So we're just using a list slice. So while I is 4, it's going to check these numbers, and here. 2, 3, 4. So essentially, it's going to check from here and here backwards to see if they're the same. If they're not, the while loop's going to iterate again and subtract 1 from I. So I is now going to be 3. It's going to check from here back. And it's going to continue doing that till there is a match. Or if there's not, then you don't win. If there is a match, then we're going to go to our if statements. So I would be 1 in this case. If I is 1, well, you don't win anything because the Powerball the Powerballs here do not match. I know it's not a great explanation for this nasty code here, but hopefully you guys kind of got the gist. And then here is just our main function. It's going to create a Powerball, check Powerball. And the argument's going to be my numbers that I selected at the beginning. And if I run this, let me type in a couple numbers here. I'm going to have it run 10 times, checking my numbers. And lo and behold, I didn't win a single time. So if I would have commented this a lot better, then I could have explained it a lot better, but I didn't. But it works, ugly as it is.
I understand it. It's okay. All right. Awesome. Um, so appreciate the demonstration. Um, the only reason I asked for a volunteer is for anybody that wanted to complete this. Um, the people that are going to see the recording, they can see an example, right? For better or for worse, they can see something that's complete product. Only because we didn't have time. But all right, let's go ahead and continue for today, right? Today's our last assignment, right? Which is gonna be our mini project 3. All right, the last assignment that you guys will be doing with me, unless you guys decide to, you know, join and you get accepted and you do foundations of programming. I'll see you there. Um, but all right, so mini project 3. This is a typo. I don't know why it says 2. Um, but it's okay. So we're going to continue with using Python to kind of make a game for ourselves. Yesterday we simulated uh, the Powerball lottery, right? You saw how we were able to leverage code to make a representation of what the Powerball lottery does. Today we're going to be working with poker. Um, Personally, I don't play poker, so I'm not the best at this. Uh, I don't do anything apparently. Jesus Christ. So we'll talk to poker. I might have to do some quick Google researching, right? But poker is a game that comes in various forms. It is a game played with two or more people, right? So the maximum player count is determined by the type of poker game. The way the cards are dealt can vary wildly, but the base concept is the same, right? A player wants to get the best five card hand possible, right? And this is what this mini project is going to focus on. It's going to be the whatever hand you have, right? We're not going to do a complete poker simulation where you have a bunch of players, you have a dealer, nothing too crazy. It's going to be very simple. We're essentially going to be creating, a player hand, and then ranking it against what it should be. I think we're supposed to create somebody else to play against. Let's see. There are many factors that drive poker gameplay, such as bluffing, but there's always one final comparison that determines a winner of a hand, right? And here we have a small little ranking of what that looks like. This is too small, so let's go ahead and look up poker car or hand rankings. And I'm only looking this up so we can use it because you're gonna need it for the assignment. I am not a robot. Um, I think they should be good. Yeah, the 10, 1 to 10. It should match what we have here. Royal flush being the highest. Yeah, okay. Bottom one being pair, two pair, 3, 6, 9. Okay, so the hand rankings we have here in our assignment only has 9. This one has 10. You guys can decide to use the high card or not. If you are a big poker fan and you know this is something that canon, then sure. But the point is we will have some kind of chart here that's going to let us know what is supposed to be the winning hand, right? You guys can do a little bit more research on this on your own if you like. But the strongest, I guess, combination of cards is your royal flush, right? Where you have all the what do you call it? The A, Queen, King, Jack, and the 10, right, of the same suit.
Face.
Um, the faces, there we go. The face. Okay, appreciate it. Yes, you guys, the faces with all the same suits. Here, straight flush. It's straight numbers, right? 8, 7, 6, 5, 4, or upwards, essentially of the same suit. And I think it's two people get like a straight flush. I think you go by who has the highest combo numbers, I guess. So there's ways to go about this. You can do more research on your own for this if you want to make it more elaborate. But this is what we'll use as a basis to kind of get our game going. All right, so where to begin? Going back to problem solving and competition thinking strategies we learned at the beginning of the course. How do we get started? So essentially, what should happen is this one should be a fairly simple one and pretty straightforward. What you would essentially be doing is trying to uh deal cards, right? Maybe deal cards to two different people. And the goal will be to compare who wins, right? Depending, player one and player two, what cards they have in their hand. You pitch them against the rankings, and then you determine who is the winner, right? So I feel like this one will require a little bit less code than what the Powerball required. It's just more about using your imagination for this one. Okay. So once again, you might want to create some kind of data structure that's going to hold your rankings, right? That you can reference, or you can hard code. You can hard code them if you want. The point is just find a way to make sure that you can figure out what the hand of each player is, and then be able to pitch them against each other, right? They should have an order of which one is better than the other. All right, how you do that is going to be up to you using everything that you've been learning throughout our program. Um, there is no right or wrong answer, right? You're going to find different ways of doing it when you see everybody's code or when you do a Google search. We're gonna break up into teams of 3 again. There is gonna be one team that has 2 people. If for whatever reason, like someone loses a person, I might kind of readjust them. So if you get moved around or you get an extra person, don't be surprised for that. One thing before we do break up the teams that I just want to reiterate, Don't go straight to ChatGPT, right? Don't go straight to Google. Uh, I want you to open up a raw Python file and start from scratch. Get with your partners, and talk. Where do you guys want to start? What are you guys thinking? Where's your thought process at? And then kind of listen to each other and pitch ideas to each other. If you have already completed, like Keegan, don't just go and be like, "Here, well, this is what I got," and then share your screen and then show them all your code, right? Although I know you're very excited to show your code to other people, let other people kind of get a start at it, right? Get a fair try. Right. So without further ado, let me go ahead and pause the recording. All right, welcome back, guys. As I was mentioning before I started recording, it was nice to walk around and look at everybody's code. Everyone had a different approach of how they wanted to engage it. And of course, the first thing I saw, most people tried to hard code it, which is understandable, right? You know, uh, one spade, one jack, yada yada, and so on and so forth. But and a good job. Every single one of you guys had a good approach. Different ways of doing it. They would have all reached the same outcome eventually. Um, but let's go ahead. We're gonna talk a little bit through the problem, and then I'm gonna save some time before the end of class to make sure that we can have like an open Q&A if anybody has any questions about what to expect moving on. So we won't get through the entire thing. I'm gonna try to get to at least one combination that we can check against, right? So let me go ahead and share my screen. Okay. We should all be looking at my screen right now. I was messing around with some code to see how that would work. Okay, we're looking at my VS Code. All right, so we all took the same approach, right? And the biggest approach that seemed to be like what that worked the most was uh not essentially hard coding every single card in every phase, but we took a direct approach and we leverage our data structures in our for loops, right? So the first thing that a lot of us did was we created two different data structures, right? We created a face data structure that was going to house the different faces that we might encounter in our deck, and then we also created let's call it ranks. Right, we created another data structure for our ranks. Now, um, without actually hard coding every single card, all 52 cards, we are able to create a deck to house all 52 cards with less code and less typing, right? And the easy way of doing it was identifying the possible faces that we might encounter, which is going to be let's say hearts. We had spade, we had club, and there was what was the other one? Heart, space, club, diamond. There we go. Sorry, I was having a brain fart, right? These are pretty straightforward. We only have four, so this was the easiest one. The next one was every possible rank that we might encounter. And we know that we kind of start at two. The A technically is kind of like the first one, but the value of the A is, if I'm correct me if I'm wrong, it seems to be higher than all of these cards when it comes to ranking. So we're gonna start at two. So it's gonna be go 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go to the jack, the queen, the king, and the ace, right? And this is what our rank should look like. Now we didn't hard code every single card, but we did have to hard code a couple things to leverage this, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 items here and 4 here, so 18 things that we had to type out. And now that we have our faces in our ranks, instead of doing typing in deck is equal to and going like 1 of hearts, right? And then 2 of hearts, we're able to take advantage of the fact that we have for loops. So what I'm going to do is I'm going to create a deck, which is going to be the deck I'm going to use for my problem. And the way that I'm going to populate this deck is going to be as simple as looping through all my ranks. And for every rank that I encounter, there should be 4 different versions of it, right? We should have the two of hearts, the two of spades. I misspelled this. The two of spades, two of clubs, um, two of diamonds, right? And that's it. There should be no other possible variation of the two. There should not be 3 two of hearts, right? Um, so to do that, we're going to iterate through our ranks. We're going to say 4 rank in ranks. That's going to allow me to grab 2, 3, 4, 5, so on, etc. And every time I get a new rank, I'm also going to iterate through my faces. So I'm going to say faces. Let me change it to plural. So I can say for face and faces. And all I'm going to do is every time I grab a rank in a new face, I'm going to append this new card by saying deck.append. And what I'm going to append is going to be a tuple, right? We have different data structures that we can use. A dictionary seems a little bit too much of an overkill to just add 1 key value pair. We could probably use a set if we wanted to as well. But a tuple works just as fine, right? As we know, tuples are typically used for constants, right? For like a grid coordinate, maybe like a radio frequency. These things don't really change. And this card shouldn't really change either. So we can use a tuple here. This is it's pretty applicable here to the situation. And within this tuple, we're going to create this card combination, right? Where we're going to add the rank, comma, face. This is going to iterate through all the ranks and create 4 different versions of these cards using their respective faces. And we can then, at the end, print out deck just to make sure that this is giving us exactly what we're looking for. And we see here a list of tuples. Now, to make sure that this is actually 52 cards, I'm going to go ahead and print it out with the length version. And I see here that I got 52 cards, right? So this successfully creates my deck that I'm going to be able to use to create the hands that my users are going to use. All right, let me go ahead and clear my terminal. Now, if you want to, you could probably do this in a function. If you have like a game that you're going to consistently run, and you had to create multiple decks throughout different parts of the game, different game sessions, you could most definitely add this to a function if you're going to use this often, but we don't have to. It's okay. We'll keep it simple. But if you did want to do that, you would do define create deck, right? And then you could just add all this within here. At the end, you're going to return deck. And you can say deck is equal to create deck, opening close parentheses. And
Player
now,
one.
what was that? I got a hot mic. Okay. Well, there we go. Right. So if you are going to reuse this code multiple times throughout your program, you can most definitely put this in some kind of function and then just reuse it everywhere around your game. Right. But yeah, so let me go ahead and minimize this, get it out of the way. I know it works. I don't need to keep looking at the code. I'm not gonna come back here and keep messing around with it. So I can just go ahead, minimize this, keep that out of the way so I can continue with my program. So cool. I got my deck. Now the next thing, what can you guys think of that is probably a good idea to create? So we have our deck. What else do we need?
Need to deal the hands.
Yeah, we need deal hands, right? So I saw some people try to create individual players, right? Create functions to create players. This is going to be a very simple program. Absolutely, you guys could create more players if you like, make it more complex. But for time and simplicity, there will be just 2 players. So what I'm going to do is I'm going to create a function that's going to deal the hands 2 players right off the bat, right? We don't have to create individual players and whatnot and do anything crazy. All right, I'm sorry. Excuse me. I burped. So what I'm going to do is I'm going to create another function that's going to say create or deal hands. All right, something simple. Now, if I'm correct, a hand is 5 cards, right? Now, I think there's more complexity to it. I think, you deal 3 cards and then people go through a level of like, betting, so on and so forth. They deal a couple cards to the table, they see what kind of combinations they might have, they raise the stakes. We're not doing anything crazy. All we're doing is just dealing hands, seeing who can draw the biggest hand, right? It's a very, very, very simple version of poker. So I'm going to create 2 players, right? I'm gonna call this player 1. And this player 1 is going to have a list to hold my cards. And then I'm going to create another player to hold his cards, right? So player 1 and player 2. Now here comes the difficult part. I want to ensure that each one of these players gets 5 cards. I'm actually going to use one of the methods I saw from one of the rooms, which is Scott's room, which is, what I'm going to do is I'm going to iterate through this deck, right? I know that each player only needs 5 cards. So what I'm going to do is I'm going to iterate through this deck 5 times. And every time I iterate through this deck, I'm going to grab one of the cards for each player and assign it to their respective quote unquote hand. They leverage a method using the random module. And if I'm correct, it's called the random.shuffle. Is that correct, Trevor?
Yep, it is just random dot shuffle.
Yeah, so we're gonna go ahead, come up here. I'm gonna say import random. Now, you most definitely can iterate through here, and I can show you both ways how we can do this. We can use the random module to randomize it. So what you'll do, you can say like randomize deck is equal to random dot shuffle, and then you pass in the deck. Is that correct?
Yep, that's correct.
We'll say incoming deck, so we don't have conflicting variables names, right? And this should randomize it. And for the sake of ensuring that this did randomize it, because I've never used this method, I'm gonna go ahead and print out randomize deck, and then I'm going to call this deal hands function. Because I'm not trying to return anything, I don't have to put print here. I'm just gonna go ahead and print it whenever the function does run. So I'm not getting that weird none thing being printed out. And let's try it out. Deal hands missing 1 require, yep, because it requires a argument, because that's how I set it in the definition. And then let's go ahead and do it again. And it did not print randomized deck.
So we did ours outside of the function, just right below where you created your deck. And then it just automatically creates that shuffled deck before you start.
It should still do this. What's confusing is why it didn't print anything out.
I wonder
So
if it's because you have so many, you have randomized deck and you have incoming deck and you have deck that you're calling on later.
randomized deck, it's going to take incoming deck, which is set as the argument. Right, incoming deck. So whatever gets passed into this function, that's what's going to take place of this argument. That's what I'm going to use for the random.shuffle and assign it to randomized deck. And then I'm going to print it out. Let's just go ahead and return it. Actually, let's see. Actually, this none statement is coming from this. So something's happening here that it doesn't give me what I wanted. Random.shuffle.
Could you do it without passing in the argument on the function and just call deck to it, to the random shuffle?
Oh, I see. Okay. Okay, so I misunderstood. Maybe I think you, Trevor, you answered this, but I didn't. I was hearing you, but I wasn't listening. So it's very similar to the sorted and sort method, right? One will actually change the original value that you're calling the method on, while the other one, it won't change the original. It'll create a copy and you can save it. And that's how I used it here, which is incorrect. the way this will be done, it would be incoming deck dot shuffle. I'm sorry. It should be random dot shuffle incoming deck. And then I should be able to do print incoming deck. Let me just verify. This should work now. And there we have it. 3 spades, 9 hearts. It's completely shuffled up, randomized. That's cool. So that worked. Now let's go ahead and continue moving forward with this. So I could have easily done this. There's another method we could have done. Why I want to talk about this method is because you guys have not learned the shuffle method, but there is one method that we have learned, the random, right? So although you didn't have shuffle, I know I taught you random, so we could have leveraged the random, right? So I can say, I can do this. I could for I in range of 5, because I'm gonna do this 5 times. I want to create you know, let's say card dealt is equal to, I'm going to access the incoming deck. And then for the index, I'm going to give it random.rand int. And then I'm going to give it a range from 1 through 53, because it's up to, but not including, I'm pretty sure. No, my bad, including both endpoints. So 1 through 52, right? And what this will do, it'll create, actually, let's change this up. I'm going to do it a little bit different, and I'll tell you why. Or as it is right now, what it'll do is it's going to grab a random index generated from this random method, and that's the card I'm going to access and save into card dealt. The issue now is what's happening to that card after I've used it, right? Chances, like there is a chance, there's a 1 in 52 chance that I might encounter it again. So what I can do instead is, let me go ahead and save this to chosen card is equal to random.randint 1 through 52. And now I use this instead to grab the card. And then I'm going to say incoming deck.remove chosen card, right? So it's a little bit more manual. The shuffle was pretty cool because you could just randomize it and then we could just remove it using a dot pop method or whatever. Here, if you aren't using the shuffle method and they're not randomized, you have to kind of get rid of a card in some shape, way, or form to make sure it's not being repeated. Also, you want to use the random method so you can get somewhere around the deck, right? It's not just in order. So there's 2 ways of going about this. Whichever method you decide to move forward with is going to be up to you. But I want to make sure I showed you the way that I taught you, so I did so. So let's go ahead and I'm going to remove this again. I'm going to make sure the incoming deck is shuffled. And now, as I iterate through this for loop, what I'm going to do is I'm going to say player 1 dot append. And what I'm going to do is I'm going to call that incoming deck. And I'm going to pop either the last one or the first one or whatever you want to pop. You can just pop one of the items from this list. Now, why does the pop method work? If you guys recall the way that lists interact, right, the list methods, there's a couple ways that you can remove items. One is the dot remove method, right? The dot remove method will delete the item that you specify at a specific index. The pop method will remove something, but it'll also return to you the value it removed from the list, where the remove method does not do that. It'll just delete the item from the list, and that's it. The dot pop methods, the way that it works, it'll return to you the value that it just removed, and we can use that ability to work in our favor. So whenever I pop something out of this shuffle deck, it's going to return back to this area right here, and I'm immediately appending it to player 1. So now that removes the possibility that I'm going to encounter this card again because it's no longer present, and it's now within player 1's hand. And at the same time, I'm going to say player2 dot append incoming deck dot pop, and just pop another value from this list, right? So both of these are going to get cards, right? They're both going to get 5 cards. By the end of this for loop, this is iterated 5 times. 10 cards have been removed from the deck. So what's next? What's the next issue that we see here that we might encounter? I created my player 1 list and my player 2 list. Scott, you guys encounter this problem. What's the problem that we have to deal with now?
Returning them back outside the function to compare them.
Yeah, return them back, right? So typically return only returns one value or one statement is a better way of saying it, right? It's going to return one statement. So you might feel inclined to do something like return player 1 and player 2, right? You would think that might work. You might try return player 1, and then the next line you might try to do return player 2. This won't work either. The moment it reaches return, it's exiting the function and returning back with some kind of value. Well, we need to be able to grab both these values. So the way we're going to do that is we're going to wrap this bad boy in a tuple. We're going to say player 1, comma, player 2. So this is a tuple of 2 lists, right? The same way that we create tuples for our card combinations, we just created a tuple with 2 lists, and it's going to return them together inside this tuple, right? So whenever deal hands runs, let me go ahead and print deal hands, and I'm going to pass in deck, and this should work. There we go. We see here that this is a tuple. I know it's a tuple because of the parentheses that are outside of it, right? It's telling me this is a tuple. The first item is a list because as you see here, after the parentheses, there is a square bracket. So that tells me the start of a list. And if I follow that square bracket, I see it end right here. So this is the first item inside this tuple. And then there's the second item and the next part of the tuple, right? So we got 2 lists in here. One belongs to player 1 and one belongs to player 2. Now, what I'm going to do is I'm going to do something called variable deconstruction, right? The way that this is done is I'm going to create 2 variables here. I'm going to call them player 1, comma, player 2 is equal to, right? This creates 2 variables, right? We are used to doing something like player 1 is equal to, and then giving it a variable. And then the next line, we create the next item. What I'm just going to do here is I'm going to create 2 variables in one line. And the only way this works is that whatever you have on the right side, it has to be able to deconstruct it, right? It has to be some kind of data structure or data or some variable that has the enough values to cover the 2 variables you're trying to create. So in here, I'm going to call the deal hands method, pass in the deck, and I can then go ahead and print out player 1, and I'm going to print out player 2. And as you see here, it's going to print both these out. It was successfully able to run the deal hands method, which as we know is going to return a tuple with 2 lists. Once this returns a tuple with 2 lists, it gets assigned to 2 different variables. The syntax here is going to deconstruct my variable and assign it to these 2 variable types, right? And then I'm able to use both of the items from this tuple. Now, you don't have to do it this way. You can use deal hands to create 1 player, right? And then just run this function twice on 2 different variables to get a list of random cards. That works fine too, right? We could have made it just create 1 list of 5 cards, return that 1 list, and then just run this function twice, right? So you don't have to do it this way. You can do it a little bit more manual, where you deliberately create 2 different players, right? I just wanted to knock out two birds with one stone. It's in one function, right? So cool. We now have our deck, right? We now have our two players. Now it's time to play the game. It's time to play the game. If you know where that's from, then you're cool. All right, so I have my two players. Next, I'm going to create a new function. Let me go ahead and minimize this. I'm going to move this to the top. I can keep my functions together. Oh no, what happened? Oh, it don't like this. What is going on? I don't want to mess with this. We'll just keep it like this. Create deck, deal hands. I don't know why that's this way. That's fine. Whatever. We create our deck here. We create our deal hands function. And we now have two players. Let's go ahead and create a new function. And this is gonna be called check hands. So we create deck, we deal hands, and then we check hands. This function should be able to, let's say, I guess take both players. We'll say P1, comma P2. Right, this is supposed to be player 1 and player 2. It should be able to take in two different lists, and these are the lists it's going to use to compare against hands. Right, make sense? So here's the tricky part. All right, and we'll only do it. We'll do one real quickly. How do we check for a royal flush? How do we check for a straight flush? How do we check for any of this stuff? Who has any ideas?
So we were toying with the idea of, taking one list and saying, okay, access for the I think it was the straight, whether if they're all the same suit, then we could say, okay, if index 0, 1 is equal to 0, 2, or 1, 1 is equal to 2, 1 is equal to, and blah, 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 blah. That would be whatever all a
Okay.
flush.
All
That
right.
was all what we came up with an idea for.
Yeah, you're on the right track, right? And like I told Keegan's team, I'm gonna be straight up. It's not gonna be pretty. It's gonna be a lot of code, right? Because there are different scenarios that we have to take into account for, right? There's 10 different possible hands, and then from those 10 possible combinations, there are different variations of them, right? We're not gonna get that deep into it, but I can show you at least one to get your mind thinking on at the right, get you in the right direction. So when you go and you mess around with this on your own, you know how to continue this. But what's probably gonna have to happen is we're gonna have to create some different mini functions to handle different hands, right? So I put pass here, so this doesn't give me an issue. But right above it, I'm gonna go ahead and I'm gonna create one small function specifically just for royal flush. Right? We'll start from the biggest to the smallest because these are pretty easy. I'm gonna call this is royal flush. Now, please bear with me because I did not finish it. I was dabbling with it while I was bouncing around rooms. But this should be able to take in a hand, right? This should be. Did I? Okay, all right. This is not a reserve. Okay, I haven't used it. All right, hand. It should be able to take in a hand, one of the player's hands, whatever, right? And then from this hand, we should be able to identify whether it's a royal flush. Well, the computer does not know what the heck is a royal flush or how it even defines it, right? But we know, right? We know that a royal flush has a very specific combination. And that combination, it has to be A, Q, K, I'm sorry, A, King, Q, J, and a 10. So we're going to use that. So what I'm going to do is I'm going to create, let's say, royal ranks, right? Or we could say you keep it generic. We can say card combo is equal to. You can make this into a list. So we can say we'll start from the top. A king, queen, jack, and then it's supposed to be a 10, right? Um, yeah, there's no suits here involved just yet, right? This is supposed to be the card combo, right? We know this is what the combo is supposed to be. So how does this hand supposed to look like? Let me go ahead and print hand because I already forgot. Print hand. Let me go ahead and pass or call is royal flush. And I'm going to pass in player 1 so I can start experimenting with this. And let's run it. Okay. This is what it looks like. 10 hearts, queen, ace, Qs, and 4s. Right. So first and foremost, we have to make sure that the faces match this combination. Right. So we should be able to say, we're going to want to iterate through hand. So we'll say for card in hand. Right. We want to access each one of these cards. And we know that these are tuples. Right. We'll say hand faces is equal to open and close square brackets. I'm going to create a list here to figure out what are my what's the faces of my hands for this specific hand, because I don't know, right? I'm getting this function is going to run is going to take a random hand every single time, right? Every single time this we're checking for a royal flush, it's going to be a different card combination. So I have to deconstruct, right? I have to deconstruct the hand that I'm working with. Or I can just say for card in hand. Actually, let's put a pause on this. Yeah, let's not use this just yet. Let's try a different method. I'm going to iterate through this list of tuples for card in hand, print card. They should give me, yeah, I'm iterating through every tuple. I could say if card not in card combo. If one of these faces does not exist in my card combo, what does that tell me? It's not a royal flush, right? Because the royal flush is this combination. It has to be an ace, a king, a queen, a jack, or a 10. If any of these cards are not these specific cards, it is not a royal flush. Plain and simple. So as I loop through this hand, I'm going to check if it's in that card combo. If card not in card combo, I'm going to return false. Right off the bat. Right. So that checks the, oh, my bad. I'm not specifying correctly. If card index 0, I'm pretty sure I can use index. I think this is working. Print this card does not exist. There we go. Yeah, 7A. So it's going to check index 0. I didn't get an error, so I'm able to use this effectively. I can index into the set. Index 0 is my faces. I'm checking the card combo to see if it's in there. It does not find it, so it returns false. Cool, it's working. So this checks the face. And now let's say, let's check if the suit matches. The suit should all be the same, right? So, yes, Chris or Scott.
I was wondering, is this one of the spot? I know you said you don't like sets, but is this one of the spots where a set could come in handy since they're, if you sort it and then typecast a set to it, you could check if it's not exactly that card combo and all of one suit.
Yeah, you're right. It definitely can.
That's a good idea.
We could probably create a set out of the suits. How do we do that?
I'm just ideas guy.
We would access the index 1 of card Well, we could just make a new set variable equal to the first index of every card, and if that set is length is greater than 1, that means that we have 2 sets, so it's not a flush.
Say that again, because you lost me.
Okay. So if we're making a set out of all the suits in a hand, if there is more than 1 suit in that set, that means it's not a royal flush. So if the length of that set is greater than 1, then it's not a royal flush.
Right. How do we just deconstruct all these sets and add items to a set? Because what's one thing about sets?
They're immutable.
They're immutable. Can you add things to them?
Okay, so we
Yes, you
sort.
can add things to them.
Can you?
Yes, you can.
Insert, or am I thinking of
You can
tuples?
add.
Let's go sets, add set items. Yeah, dot add. Yeah, we're thinking of tuples, Scott. We can add. Absolutely. Let's do that.
So would you want to sort it first, since you can't sort it after? Because it's ordered, right? Like once it's in an order.
You don't necessarily have to order them. I mean, it could be as simple as like we don't have to do that. We can just say suits. Suits is equal to an empty list. As we iterate through here, we can say elif
Like we could do it above the if statement, like suits dot append card index 1.
if suits dot append. Well, we want to make sure that it's in there or not in there.
Oh, we could do it.
If card index 1 is not in suits, right? Then return false. Else card 1, we want to say suits dot append card 1. Suits dot append card 1. Right?
Oh, we
So
want to not in suits. That would return false immediately. So we would
So
do.
you're right. If it's not in suits, okay, here we go. If card 1 not in suits and the length of suits is greater than 0.
Okay.
Right? So
Yep.
for those of you who I'm losing here, because I know there's gonna be a couple, y'all. When we check the suits, there should only be 1 suit inside of this list called suits, right? Because they're all the same. So there should not be multiple suits of spades. Make sense? So if I encounter a suit that is not in here already, right? And I've already encountered a suit, then that means one of these cards is a different suit. Make sense? But if the first card I'm on is 9 suits and we still haven't added anything in here, that means this is the first time we've iterated through this card and we're finally adding the suit in here. So yeah, I think this will work here. Right? And then we're gonna go to elif. Oh, my bad. And we're going to grab this. And I think this should work. Right? For card in hand, we're gonna check the suits. If it's good, then we should be able to move forward. But we need to add it in here at one point. Right? It should be suits. Now we're good. Yeah, I think this should work. Yeah. Anybody see anything? I think this should work. We're checking if the suit's not the same. This will pass. Then we check if the card combo is there. If it doesn't pass, it will false. If not, then we should add the suit into our suits list and continue. And then the card combo should continue moving on like normal. And they should check whether it's in here or not. Now, once this for loop is done, we check all the possible combinations. I'm going to return true. Right? So whenever I run this is royal flush method in my check hands function, it's going to, I should be checking for true or false. If it returns true, then I'm going to say, I'm going to compare this royal flush. I'm going to say player one, it has a royal flush, whatever you want to call it. And then you check player twos, right? So that's all I'm going to do so far. It's 8:43. I want to leave some room for any kind of Q&As, any conversations. But this is kind of the route you should be taking with your combinations, right? For the different hands that you may encounter. A lot of these are going to be very unique, right? There's going to be a couple that are going to be very similar, right? The royal flush all uses the same suits. The straight flush uses the same suits. The full house, no. Here we go. The regular flush uses the same suits. Yeah, so there's three right off the bat that use the same suit. So this code will be able to be used in other places, right? So I kind of really helped you out with three of these. So with that logic, you should have enough to kind of go off and be able to recreate the other possible combinations.
Can we test it real fast? Just I just sent a test, like hard coded hand.
Absolutely, absolutely. Thank you. Yeah, we can definitely test it. Test royal flush. And let's go ahead and send this test royal flush, and let's see if it works. You put him on the spot on camera. It is printing something. It is returning. Oh, I'm printing right here. My bad. Printing right here. And I need to print what's coming back from the royal flush to make sure it's doing what it should be doing. So I can see true or false. And it says false.
This is kind of the question I had. Does the order of basically index one and all of those, the face value or like the card values themselves matter in the order for card?
The 10 is an integer. I don't know if that's going to impact it.
That'll absolutely impact it.
Hearts. Let me just check my deck. It's all lowercase. Yeah, let's try it again. There we go. Damn. I almost missed that too. I was like, there's no way. I thought this is foolproof. But yeah, there we go. It's working, guys. Do you have any questions? Michael, give me a round of applause. Awesome, awesome. Thank you, thank you. What was your question? I'm sorry, I didn't mean to cut you off.
So why doesn't the card combo order matter when checking? I'm just kind of trying to run that through my brain.
The card combo, because there is no other possible combination for the royal flush. It's set in stone. It has to be the ace, the king, the queen, the jack, and the 10. So it doesn't matter what order they are in, as long as all 5 of them appear, then that's good, right? If any of these are missing, then that's an issue, right? The order doesn't really specifically matter to the royal flush, right? I'm not saying that it won't matter for other ones. The straight is going to matter, right? Because there is a specific order for the straight. So you have to make sure that it is in an increasing numerical order. So that's where it's going to matter. For the ace, it doesn't necessarily matter. As long as all 5 of these appear, I know that I can sort these and they will be in order. Does that make sense, Trevor?
Yeah, that makes sense.
Awesome. All right. That's going to conclude the poker hand assignment. If you guys have any questions about it, let me know. I can answer your questions after class. I'm going to go ahead and stop the recording now.